All right, so I've drawn a graph here, so you can kind of jot that down on your paper if you'd like. What we're going to do is we're going to be talking about the absolute max and absolute min. So these two things you already know. The very, very highest, the very, very lowest, right? Very, very lowest y value. So on the very, very lowest y value, absolute min on this graph would be at f of -3. Okay, so I want you to get in the habit of identifying the x value that the minimum is occurring at. And then the very, very largest y value, I tried to draw it as this one up here, make it a little bit higher there. So the very, very highest y value would be f of -5, right? Okay, so very highest y value, very lowest y value. These are called extreme values, and sometimes we use the word extrema when we want to say find max and mins. Okay, now local maxes and local mins, what that means is that there is an interval around which, so this would be the local minimum, right? This point right here, down here would be the local minimum because there's an area around where that's the lowest. So a local maximum would be, there would be an area around where that's the largest. So this has to be a peak. And this has to be a valley. So it cannot be an end point. There has to be a region around that gives you a local extreme value. So let's go through this graph. So this point right here, f of -5, we already determined was the absolute max. It's the very, very highest y value. It is not a local max because it does not have a region around it. Let's look for some local maxes. So some local max would be, so look here at this point right here at f of 0, there's a region around where that's the highest y value. This right here at f of 5, there's a region around where that's the highest y value. And then also f of 9. So there's these are all peaks. You want to think of them as peaks. Okay, so how about local minimums? Local minimums, so where there's a region around where it's the smallest, like a valley. Right here at f of -3, there is a region around, so that's a local minimum. At f of 2, that's a local minimum because there's a region around. Now if I look at x equals 7, there is not a region around where that is a minimum, so that is not. So those are the only, so these are what I would call the valleys. And that is explanation of local extrema. All right, so now I want you to look at the graphs of these different items or functions on different intervals. So you know what the graph of y equal ln of x looks like. ln of x looks like this. So here's 1, and 8 would be out here. So I'm including 1, but not including 8, right? So if I was to get a different color pen going here, so this is the part of the graph that I'm looking at right here. All right, so I want to find the absolute and local mins and maxes. So from looking at this part of the graph, I can see there is an absolute minimum at f of 1, the y value of 0. There is no absolute maximum because of this open hole here. It never reaches the highest y value. And there are no local extrema because there are no peaks or valleys. Okay, so let's look at sine of x. So sine we know looks like this between 0 and pi. And so that's 0 and pi, including the endpoints. So I know that there is an absolute minimum at the same y value of 0. So f of 0 is the same as f of pi, and those are both 0. Again, it's the x values I want you to identify more than the y. Let's see. Yeah, there are no local minimum because there are no valleys. There is an absolute max, and it's the same as the local max. And that occurs right here at pi over 2, the highest y value right here. So that occurs at f of pi over 2, and that's 1. All right. You know this graph of x to the 2/3 looks like this. So I want the part of the graph that's between -1 and 2. So let me try and draw it over here, give context. So it's going up still. Okay, so the part of the graph that I want here, down to here, and up to and including that point. All right, so I can see there is an absolute min, and that's the same as the local min, and that's occurring at f of 0 at the y value of 0 right here. As far as an absolute max, that's occurring at f of 2. This is a filled in y value. There is no local maximum because there's no peak. No peak or area around which there's a highest y value. X to the 1/3, you know, is a graph that looks like this. So the part of the graph I want is between -1 and 2. Include -1, but don't include 2. So this is the part of the graph that I'm looking at. Right. So see, I can see I have an absolute minimum that's occurring at f of -1. And there is no local minimum because there's no valley. No valley. There is no absolute minimum, or I'm sorry, no absolute max. There's none. And there is no local max because there's no peak. So there's just 1 there. All right. 1/3 x, you know, is just a line. Slope 1/3. So between x equals 0 and x equal 2, so this part of the graph. So I see I have an absolute max at f of 2. I have an absolute min at f of 0. No local extrema at all. Last one here, cosine of x. So cosine, you know, is like this. That would be between 0 and pi. So here's pi, right? And here's 0. All right. So this part of the graph, so do not include this point, and all the way down and include this point. Okay. So there is no absolute maximum, because this is an open hole. There is no local max because there's no peaks. There is an absolute minimum happening at f of pi. It's at -1, and there's no local minimum because there's no valley. All right. Issues here. Okay.